Hey guys, it's Miss Johnson and I'm here to bring you our notes for Unit 4 Learning Target 9. This is our last notes video for Unit 4. Today we're going to talk about quadratic applications. So when we are asked to find the vertex of the question, it's because we are being asked for a minimum or maximum. When questions reference the minimum or the maximum of a parabola or of a model or of an experience that's happening, that means that you are supposed to find the vertex. The vertex is what gives you the minimum and maximum of a quadratic expression. So here's just one example to look at. It says the path that a skateboard rider follows during a jump is given by the equation y equals negative 0.5x squared plus 5x plus 8, where x is the horizontal distance from the edge of the ramp and y is the height in feet. What is the maximum height of the rider during the jump? So the fact that you see this word maximum here, hopefully that word maximum now tells you, oh, that means I need the vertex. So this is an opening down parabola of some kind, which makes sense because if you've got a person standing on a skateboard, they're going to jump that skateboard up into the air and they're going to go back down to the ground. So we want to know what is the point at the top, okay? How high is that point? So in order to find that, we need to find the y value of the equation. Well, to get the y value of the equation, we have to start by finding the x value of the vertex. So we're going to do the x value of the vertex. If you think back to that, the x of my vertex is the opposite of b over 2a. In this case, that is negative 5 divided by 2 times negative 0.5. So then when I multiply that denominator, I end up with negative 5 times divided by negative 1, which is just positive 5. So that's the horizontal distance in feet, but the question is, what is the maximum? So in order to get the maximum, I'm going to take this and I'm going to plug it in for x and get my y value. So I have y equals negative 0.5 times 5 squared plus 5 times 5 plus 8. Plugging that all into my calculator, start by doing the square. I've got y equals negative 0.5 times 25, 5 squared is 25, plus 5 times 5, plus 8. Then I'm going to multiply, so I can multiply here and multiply there. Y equals half of 25 is 12 and a half. But this is times negative 0.5, so that's negative 12 and a half, plus 25 plus 8, and then put all those together. So negative 12.5 plus 25 plus 8, I get 20 and a half. So that is my y value, and this is a height in feet. So if I were to label this, I would say the max height is 20.5 feet. And there's my answer. So once again, I just want to point out the fact that because it asked for a maximum, that's what leads us into doing the vertex, okay? Let's look at this one. It says minimum cost. A car dealership has modeled the monthly operating cost for car maintenance work by the function y equals 0.25x squared minus 12x plus 200, where y is the total cost in dollars and x is the number of cars worked on. Find the minimum cost and the number of cars that should be worked on to yield that minimum cost. So find the minimum cost and the number of cars. So the fact that it's asking me for the minimum tells me that I'm looking for the vertex. Okay, this is an opening up parabola. My a value is positive, so it's going to open up, which means that's why I have a minimum down there at the bottom. I still use the same equation. I'm going to do x equals the opposite of b over 2a. In this case, that's positive 12 divided by 2 times 0.25. That's 12 divided by 0.5. 12 divided by a half is 24. Okay, so that's my x value of the vertex, but now I need to take that and plug it in for y. So I'd have y equals 0.25 times 24 squared minus 12 times 24 plus 200. Start by squaring the 24. So that's y equals 0.25 times 24 squared is 6 something, I think. 24 squared. Oh, 576. I was off. 576 minus 12 times 24 plus 200. I'm just going through my order of operations here. Next, I would multiply. So 0.25 times 576 gives me 144. So that's y equals 144. And then minus 12 times 24 is 288, I believe. 288, yep. So 144 minus 288 plus 200. Plugging all those in together. 144 minus 288 plus 200. I end up with 56. So I get y equals 56. So here's what that means. I have an x value of 24, and I was told that x is the number of cars. And I have a y value of 56, and I was told that y is the total cost. So that means my minimum cost is $56. Don't forget to label your 56. $56 for 24 cars worked on. There you go. All right. And that answers both parts, by the way, find the minimum cost and the number of cars. Let's talk about questions that are asking us to solve. It says when questions reference how long it will take an object to hit the ground, then we need to solve the equation and identify the logical solution. Okay. When we say identify the logical solution, often when you solve quadratic equations, you end up with two answers. Not usually, lots of times, one of those answers will be negative and one of those answers will be positive. And lots of those times, it doesn't make sense to use the negative answer. You can't have a negative time, you can't have a negative distance. So if it's asking for time or distance, then you can't pick the negative one because that doesn't make any sense. Okay, so let's take a look at our next example. It says an object is launched at 19.6 meters per second from a 70.8 meter tall platform. The equation for the object's height, s, at time t seconds after the launch is this. S of t, that's really just function notation for the variables. We could have written that as a y variable if we were using x and y here, but this is the height after t seconds is what that means there. The equation looks like negative 4.9 t squared plus 19.6 t plus 70.8, where s is in meters. Okay, when does the object strike the ground? Okay, so when means you're looking for your t time, okay? So if I'm looking for t time, that means here, if I can picture an equation here, if I picture what's happening here, I've got my coordinate plane, and then I've got an equation that looks something like this, okay? So here's the two solutions. The solutions happen where they cross the x-axis, right? So if the solutions happen where they cross the x-axis, I'm going to have one there and one there. Well, this one is not going to make sense to us because that would be a negative time. So when we find our two solutions, we need to keep the one that's positive, and that's my positive time there. Now, when I look at this equation, I recognize right away that I've got some decimals in there. I don't want to try and factor the decimals. Factoring with decimals is not super fun. So I'm going to go straight to the quadratic formula. So when I plug all this into the quadratic formula, it looks like this. I've got x equals the opposite of b, that's negative 19.6 plus or minus the square root of b squared minus 4 times a times c. And the whole thing gets divided by 2 times negative 4.9. Okay. Now let's go through the steps and solve that in our calculator. So I'm going to square, we got to start by working under the radical. So I'm going to square that, 19.6 squared. And then I'm going to also multiply all of this stuff together. Notice that I have a negative times a negative, which is going to give me a positive. So 4 times 4.9 times 70.8. And then I need to add that to the 19.6 squared. So I end up with, I haven't touched this outside, negative 19.6, plus or minus underneath I have 1,771.84. In the denominator, you can go ahead and multiply those two together. 2 times negative 4.9, that's negative 9.8. All right, so now take the square root of that 1,700 number. So I'm going to take the square root of 1,771.84, and I get 42.09. So negative 19.6 plus or minus 42.09, all divided by the negative 9.8. All right, now I'm ready to split. So I've got x equals negative 19.6 minus 42.09, all divided by the negative 9.8. And I've got x equals negative 19.6 plus 42.09, all divided by the negative 9.8. I'm going to plug those two things in. So do your numerator first. Negative 19.6 minus 42.08, or 42.09, sorry, 42.09, divided by negative 9.8. And I end up with 6.29 there. And then in the bottom one, negative 19.6 plus 42.09, divided by the negative 9.8, and I get negative 2.29. So when I look at my two results, I have to choose which one makes the most sense. Which one is going to make sense to me? The one that makes the most sense to me is this positive one, because I can't have a negative time. So I shouldn't pick the negative 2.29 seconds because that doesn't make sense. So it says, when does the object strike the ground? It strikes the ground at 6.29 seconds. Don't forget to label your answer, because this is a question with words. Every question with words gets an answer with words. All right, let's look at one more example together. It says an object directly upward. I don't know, that's not telling you what it's doing. I think it's being launched. An object is launched directly upward at 64 feet per second from a platform of 80 feet high. When will the object reach the ground? Okay, so again, you're asked for ground. Here's your equation. You've got h of t. So again, that t is often used because of time. So h of t is time in seconds. And I know it's seconds because I'm told up here that's 64 feet per second. I know that this h is going to be height. H is the height, and that's in feet. Okay, but really, the question here is when. When the question is when, that means you're looking for time. Okay, so I want to solve for t. If I'm solving for t, once again, you could do a couple of things here. You could either factor it and then solve each factored form, or you could do the quadratic formula. When I look at this equation, these numbers are kind of large. It's a negative 16, a 64, and an 80. I don't really feel like taking negative 16 and multiplying it by 80 and then figuring out the factored form from there. You certainly could. I also see that there's some common factors that I could probably divide out of there and then make it easier to factor, but I'm not even going to mess with that. I'm just going to jump straight to the quadratic formula because I think it's a lot simpler to not have to mess around changing the equation first. So here we go. I'm going to have t is equal to the opposite of b, that's negative 64, plus or minus the square root of b squared. So 64 squared minus 4 times negative 16 times 80, all divided by 2 times negative 16. All right, start with your radical. So negative 64 plus or minus, haven't changed that. 64 squared, I'm going to get a really large number here. 64 squared is 4,096. And then I notice again that this is minus a negative, which is plus a positive. And I have 4 times 16 times 80, 5,012. No, sorry, 5,020. And then 2 times negative 16 is going to be negative 32. Put that 4,096 and 5,120 together. So I get negative 64 plus or minus the square root of 4096 plus 5120. That's 9,216. And if I take the square root of that, I get 96. So I have t is equal to negative 64 plus or minus 96 all over negative 32. Sorry, I had to write kind of small there. Now I'm going to split them. So take these two and split them apart. That's t equals negative 64 plus 96 over negative 32. And also t equals negative 64 minus 96 over negative 32. And let's see which one makes the most logical sense. So negative 64 plus 96 gives me 32. I end up with 32 over negative 32, which is negative 1. Okay, there's my first answer. Negative 64 minus 96 gives me negative 160 divided by negative 32. And I get, so that was a negative 160 divided by negative 32, and I get a positive 5. So again, we're talking about time. It does not make sense to say it hits the ground after negative 1 second. Negative 1 second is not possible. We can't go backwards in time. It doesn't make sense. So I'm going to cross out the negative 1. That's not a logical answer for me. And I'm going to say that it hits the ground after 5 seconds. If I were to write out a nice sentence here, I would say the object hits the ground after 5 seconds. Oops, forgot my D there. There you go. All right. So there you have it. Finding two different things within the quadratic equation. Are you asked for a minimum or maximum, or are you asked to solve it, meaning when is it going to hit the ground? Okay, so that's kind of what we need to watch for when we look at these word problems. So that takes us to the end of our lesson. Thanks for tuning in, and I will catch you next time.